Okay, so hello again. Uh, Today is June 12th, sixth scheduling meeting. Welcome everyone. So we have two topics on the agenda. And the first one is about node capabilities cap.
Yeah, I can start. Dominic, can I get like permission to share my screen? I don't know. Uh, I don't have
Mm,
it.
Okay. Okay. Yeah. How to do that?
I guess he has to be a co-host to be able to share
I
screen.
mean, it's okay if you can just like pull up the cap linked here. Even that should work. Oh, I think now I do. I see. I can share the
Okay.
yeah. Uh, is my screen visible?
Yes.
Okay, cool. Hey everyone, my name is Praveen. Uh, I wanted to rise the visibility on like the skep that I've been working on, and also get some feedback from the scheduler point of view. So this is like the node capabilities skep, and the problem that we are trying to solve here is like currently like there is no good way for like the scheduler to understand like what features are enabled on the node. It could be like kernel or like kubelet or like runtime features, or it could even be like plugins and things like that. So I think like most users currently use some mechanisms to basically ensure that if a workload needs a specific thing that is present on the node, we currently have like tains and tolerations or like node labels and selectors as a way to ensure that like the workloads are placed correctly. But like this is a problem like with new features which are going or alpha or beta, where like because of the version skew, the control plane could be running at a higher version, while some of the nodes like may or may not have the kubelet that the feature that the workload is looking for. So in such cases, like unless you have these other mechanisms to make sure the workload is placed correctly, what could happen is like without any visibility on the kubelet features, the scheduler can end up like scheduling the pod on a node where the required feature is not enabled. So this could result in like basically like the workload uh, being rejected by the kubelet, or the even worse situation is like the workload is like silently running, and the user doesn't even know that like it's not working as intended. So the the problem of this version skew, like the way we could try and solve this is exposing some of the things that is enabled on the node through the existing node status API, by adding a field called like capabilities. It's basically like a map which includes like everything that is needed by the workload and that is present on the node. It could go into the capabilities thing. So a couple of like key requirements for things to be added onto this is like, one, it needs to be actionable on the control plane side. So it could be like, basically it could be used on the scheduler to schedule the pod, or it could be used on the admission controller, like if there is a pod request, like for example resize request or things like that, we could use it on the admission controller side to figure out if the node has like pod level resizing enabled. So this is just an example. So yeah, like this could help in bubbling up these like things at a higher level rather than like failing on the kubelet once the pod lands on the node. So, and also like basically the idea is uh like the scheduler or the admission controller is intelligent enough to look at the pod spec or like associated objects and figure out like what capability a pod needs, and then look for the capability on the node object. So yeah, this is the high level goal and a way to achieve this. On the scheduler side, like what we are proposing is to include like a filtering plugin called node capability filter, which would basically inspect the pod spec and map them to like features that are enabled on the node, and filter out the nodes that are that do not have a feature like the pod is looking for enabled on the node. So yeah, I can pause here for any questions. I hope like uh, the high level idea is like clear enough.
Yes, I think I'm already familiar with the cap, and I think it overall looks good. I have a question regarding the how those capabilities would be inferred from the pod spec.
Mhm.
So how exactly do you know which feature or code version the pod requires?
I think like the way we infer the capability is like highly dependent on the feature itself. So as a part of this skep, like we plan to use some example to indicate like how it could be used. So one of the things that I've like indicated like or explained in the walkthrough section is like basically things like if like one example that I've mentioned is like pod level resources. So currently it's enabled, it's not enabled on like Windows nodes. So basically like the kubelet will need a change which would add a capability which looks at the feature flag, and also look at like what OS the node is currently running, and exposes a capability called pod level resources support. And on the scheduler side, like we can look at the pod spec, and it is like in pod spec resources there, if like using that we can infer that the pod is looking for like pod level resources, and based on these two things like we can uh, filter out the nodes that do not have the feature. So again, like this is one of the example, but I think like by looking at pod spec like we can infer a bunch of features that it needs and use them to filter out nodes. So yeah.
Mm-hmm. So what
But
about some kernel like features?
uh like as a part of the alpha stage for this skep, like I have not included any kernel feature, but I think I've explained like one example in the like the yeah here in the story where uh like things like app armor support, or like SE Linux security modules, if they are enabled, we can publish them through capabilities. And again, this also can be inferred by looking at like security context in the pod spec and match them to the right nodes.
Okay.
But basically, it means that we will need, for every new capability, we will need some custom code in scheduler to kind of connect the capability with some pod-oriented setting, right? So
Yeah, that's right.
it will not be out of the box. It will require some, like, hopefully pretty minor, but still some changes in the scheduler itself,
Yeah,
right?
I think that's right. The way I think is like this could be one of the common like version skew management strategies that we could use in the upcoming features, instead of relying on like ad hoc mechanisms, like like feature specific ad hoc mechanisms.
No, I think my comment wasn't to show that I'm against that. I'm
Mhm.
just trying to understand the consequences.
Yeah, sounds good. Yeah, I think you're right. Like we need a change on the kubelet side, and we need a change on the scheduler side, or whichever control plane component that is looking for the capability.
So what I was just wondering, whether maybe we can somehow avoid that, and through, like, if we, like, based on some cell definitions or something, like somehow um connect the capability with certain fields, or like do some magic to have like only generic code in the scheduler itself, and not to, and somehow avoid like the changes on every single like new capability. I don't think it's like necessarily a alpha blocker, but I would I think we should
Yeah,
think about
I feel the same. It would be nice to make it generic, at least for the future gates. I'm not sure. So it could work the way that pod itself could have already the capabilities that it requires already provided when it enters scheduling.
Uh, yeah, like during the initial uh, like brainstorming, we did discuss like including things in the pod spec that indicates like a capability is required or not. I think we decided to exclude that from the alpha stage for this skip. I think it definitely needs like more consideration on like if we need to do that, and like how do we make sure basically like right capabilities are included and the node exposes the right capability and things like that. But yeah, like as a part of alpha, we decided to not do that, but definitely like worth considering for subsequent stages for the cap, I think.
Yeah,
so,
and the
so I
last
would personally, sorry, I think that I agree. I wouldn't like, I think we need a basic mechanism for alpha,
Yes.
but like I would like explicitly add a beta requirement now to figure out some more generic mechanism, like in the scheduler for consumption of those.
Yeah, makes sense.
I think we did talk about using some sort of like cell-based plugin approach for like the extensibility use case. Like say I add some system daemon that operates based on an annotation that's set on a pod. I want to be able to say only, if you set this annotation, only schedule to nodes that have this plugin installed, essentially. I think we could still explore that. Can you elaborate on why you're against the like built-in rules for the built-in types? I mean, schedulers currently only scheduling pods, which is a built-in type, so we have all the information we need in there.
No, I think
for
it's
instance,
not that.
version skew.
What'd you say?
Version skew. So the scheduler has to be in the updated first before nodes gets updated.
That's
I think that's generally true, and like we
yeah.
are recommending doing that anyway. So I think that's probably okay. The reason the reason why I was bringing it up was basically,
I think we only care about version. We would only care about version skew
5 years. We will end up with 100 of.
Wojtek, I think you have to repeat because we haven't heard you. At least me, I haven't.
So the reason I was bringing it up is basically that as long as we have like few of those in the next like 2-3 releases or something, we have 5 or 10 or whatever, that's fine. But like we will keep adding those capabilities, and in say 5 years we have 100, and it will be just like the code in scheduler will be like growing infinitely here.
Unnecessarily.
Well, I think we could factor it in a way that it's very well organized. I mean, the alternative is basically put this code in the API server, which already, has validation and all sorts of rules, like per every new field type that gets added. I think version skew is a concern if we care about version skew between the API server and the scheduler. But if I don't know how much of an issue that is in practice.
So if we sorry, going back to your previous point, if we put that explicitly in the code of the API server, I agree it doesn't really matter. That doesn't really differ from the code in scheduler. But if we somehow manage to put that into tags in the API itself, like in the specific values of the capabilities or something, that we will somehow correlate them with like fields on the pod or something, that may avoid like any code, any like non-generic code in any of the components. Maybe I'm just dreaming. Maybe it's like hard and not worth it, but
I think we will figure it out.
But to be honest, to be clear, like it's not that I think that it's a block or alpha, so it's like more future discussion, at least from my perspective. Like I'm not
I also
like
agree.
stakeholder here. But...
Well, what would be nice if a scheduler could have a well-prepared spec, what it has to do, and use as little as possible of the custom algorithms. Just run the generic one and do the work. So it would be nice to put all such custom logic somewhere. Maybe we need to have some. Maybe it might be a part of the scheduler, maybe not. Some component that would be providing those missing implicit scheduling constraints based on some logic. I think similar thing is needed in other caps. We will discussing implicit tolerations, so we will have another discussion following this one. So we can defer, but possibly we could have something like implementing those implicit logics before entering into scheduling.
I just wanted to mention another approach that we've discussed in the past is the logic of capabilities is basically labels and label selectors, or labels and node selectors. We could implement this as the kubelet adds a bunch of, like automatically adds a bunch of labels based on its capabilities. And in the API server, we automatically add a bunch of required labels to the node selector.
I don't think that this is what we would propose. I think how it is described now, it's okay. If we could make it more generic and move the custom logic outside of scheduler, would be definitely nice.
Yeah, like one small point that I wanted to bring up regarding like the number of capabilities like growing to a large number. So we discussed this quite a bit, and I think like that was the reason why like we decided that uh, all of the capabilities that should go in should be like basically actionable on the control plane side. So that should limit the number of capabilities. And the other thing that we considered was like for specifically like things that represent like feature gates, we could also have like a mechanism to basically deprecate the capability after the feature goes like GA, considering the version skew on the control plane side. So yeah, those were the couple of things like that we discussed that could kind of limit the number of capability itself, like exploding to a large number. Uh, yeah, just wanted to bring that up.
So maybe last one question. So would it be possible to write cell expressions that would filter out those pods which need some capabilities, and in this way make it just configurable?
Right now, like since it's kind of heavily feature dependent as to what pod spec maps to what capability, I see it's harder. But coming back to the earlier discussion for like a more obvious way to express capabilities like that, once we consider that, it might be possible. But right now I don't see a good way for achieving that, I guess.
Okay.
Yeah, that's everything I had, unless there are like more questions.
I think no questions. Yeah, we will review the cap in detail, and yeah,
Sounds good. Thank you so much.
follow up soon. Okay, thank you. Okay, and I think the next topic we have implicit tolerations.
Yes, thank you. So I just want to bring this into the attention and understand better. The suggested approach works best for the use case it trying to address moving forward. So for those who are not very familiar with the proposal, it's basically uh, um, aims to address the use case while the admission the cluster admin tends the nodes, and we want to figure out a way to kind of having the coordinating port has the toleration to be able to schedulable for the specific nodes. And the previous previous mechanism works for the native resources is people would have admission webhook, which based on the port specification add the toleration automatically so that scheduler would know which node is appropriate for scheduling. And the existing mechanism cannot work for DRA because we have so many different resources added, the resource claim, the device, and everything. We have so many informations, and we cannot get those information ready while the admission chain, while in the admission chain. So the only place we could get the information is the scheduling. So actually the scope of the original proposal is really not that big. We want to address, we basically want to have the end user less responsible for specific node characteristics, and supporting the existing mechanism of tense and the toleration while later when the cloud providers adopting the DRA. So my question is, do we want a more generic solution for this kind of use case, or is that okay? We just try to address the use case where the node already been tainted, but the toleration is forgotten to be added by the end user, and we want it somehow can be handled by the cluster administration through the scheduler configuration. Yeah.
So I think I had a question that in one case, so if we have prioritize alternatives and the claim requests few different options and only one of them requires like toleration because there is a taint. We will be applying the toleration for the whole claim, even though we are not going to use the GPU, which was protected with.
Yes, I agree with the concern. It's definitely a valid concern. It will end up maybe adding the toleration to the pod, which ends up not using or like allocated the pod to the node, but without using the specific resources. Is that the concern, right?
Yeah.
I actually talked the similar topic with John earlier. I'm not sure like how kind of strict we want the tenant toleration works. Is there any kind of serious consequences if we end up scheduling pod to the tenant node without using the specific resource? I mean, is this acceptable, or we want?
So probably I'm not the best person to answer this question because that's probably either users can tell. But in my opinion, tainting nodes to prevent scheduling pods that does not use scarce resources is not the best way of doing that in general. I also made that comment. I'm sorry, I haven't checked whether there are any replies.
I
But I
think
think this is a very specific case, and yeah.
Historically, this has been like common practice, actually. Sometimes nodes with special hardware were getting tainted, and only the pods that needed those resources were having toleration. So it's not completely uncommon, but it could be. I don't know, with a better API, maybe we can have more like first class.
Yeah, so I'm sure that this is the how people do that. I think we know that. The question is whether we should like recommend doing that and supporting this use case in scheduler, and this is where I'm more concerned.
I mean, supporting the scheduler already supports it, right? So putting a taint and the scheduler already supports not putting pods that do not tolerate it.
Yeah, but implicit taints. Yeah.
What do you mean by implicit?
So we are discussing the implicit taints.
Oh, implicit taints. Yeah. So this particular one. Sorry, I was not fully aware of what exactly it was. I joined a little late, but yeah, I don't know. I feel like sometimes making the API more complex is not necessarily the best way of moving forward.
So
okay.
This proposal actually didn't touch the taint nodes part. We assume like the node already been tainted, and we want to figure out a way to automatically kind of having the pod like at least be schedulable to the right node.
Right. So this is about putting automatic toleration, I guess, right?
Yeah.
So you basically look at the resources and say this is probably the pod that we want to be scheduled on that node. So what is the benefit? What is the use case for? Do you have a particular use case yourself at your company or someone that that would need this?
Yes. So I'll just fall back to the existing mechanism. So the existing native resource also facing the similar issue where like where the node might be tainted, and the user could forget to add the toleration. So the pod with specific resources cannot be scheduled. And the existing solution by multiple cloud providers, including Google, is adding a webhook in the admission chain where they would automatically add the toleration to the specific node when they detected it might need the specific resources, or it could be scheduled to a tainted node. So that's the existing mechanism, and it does not work for DRA. Because DRA has a device resource claim and all those resources, which we cannot get all the information while admission chain time. So we cannot use the webhook to do the similar thing. That's why we want to offer a approach to let the cluster admin to kind of use for adding the toleration when needed.
Yeah, I get it, and it may make sense. One thing I wanted to add is that probably scheduler is not the right controller to add the toleration, right? I mean, I understand that this may have its own merit, but not the scheduler is not the right controller for this.
The thing is I understand there has been a proposal saying adding the logic into the DRA related plugins, right? The thing is, I'm not sure. My understanding is uh, we did not know for sure which devices or which kind of be allocated at that point. So scheduler is the only place when we get all those information.
Yeah,
Because otherwise people can go wild of adding so many possible kind of resources matchings or devices, and we don't know for sure which one gonna be allocated.
So I personally think we should list a few alternatives and possibilities how to address the problem. One alternative I was describing is to indeed treat some tolerations as completely implicit, so they are not reflected anywhere. But we would have to have a deterministic logic of applying them so that any component that needs this similar knowledge would be able to do so as well. But actually there is a concern that we may need this more detailed information during scheduling, whether to apply toleration to a node or not, or to a pod. So if we don't use tainting mechanism at all, then everything could be implemented in the DRA plugin. But basically, we would have to recommend users a little bit different approach. Instead of tainting those nodes, we can think about some other mechanism to describe when to not schedule a pod. We may be indeed missing a phase in which we could, or maybe not. Maybe it's enough to do it in filtering.
Yeah, I think let's just make sure my understanding is correct. I think the suggestion is to have the logic without using taints and toleration. Of course, we need to educate the user later, but basically try to have all the logic in the another kind of controller whatsoever. But the problem would be we still need the information which only scheduling hold.
Well,
actually,
if you do it in the array plugin, then it's part of scheduling, so all the information is there.
Yeah, actually, I like that idea much better. If instead of doing the taint and providing this implicit toleration, etc., for these resources, if there is a way for us to define which resources are scarce, or I don't know, whatever you want to call them, scarce or expensive, whatever, uh, in that case, it will be much better for scheduler to, you can in the rules you can specify that this is like prefer no schedule or strictly no schedule, etc., for those resources, and then the scheduler can use this for either in the filtering phase where it's filtering out nodes, or scoring phase if it's like prefer no schedule. In that case, it's much simpler and easier because users no longer need to put taints on the nodes, and also we don't need this whole toleration. I would like that approach better, and provides us with a much more like a first-class approach to solving this issue.
I guess I just have an additional question. So the use case actually it tried to address is like for tainted nodes. So like if we going for like non-taint toleration mechanism in the future, does that means like we just gonna rely on the user to always remember to kind of add toleration to their pod whenever they migrate into DRA, if they are using taints and toleration, because the existing users still like quite amount of the users still like using the existing mechanisms, right?
Right. So
this
this,
we don't want to support this kind of use case.
yeah, essentially, I mean, in that, if we have that API, then users shouldn't taint their nodes for scarce resources. Basically, that's what it is, and they know they don't need toleration anymore. But I understand your point as well that maybe switching and moving away from that existing API needs additional work. And yeah, you're right in that sense.
I think maybe it's not like the question is what use case we would need to support. And if I understand correctly, the use case is providing toleration in case user forgets to put it into pod. So
Yeah,
I think
later while they migrate into the array. Yes.
Yeah, I think it's not a critical use case. I of course understand the problem, but it's not like we don't support something, because users can still put explicitly tolerations whenever they admins use taints. So that's agreement between admins and users. So they should basically comply, and they shouldn't forget.
I am not sure if that's the case for especially managed cluster currently, which is quite popular in the existing cloud provider offerings, right? So
I mean, it's not about forgetting, but is it the main?
Because user does not need to worry about it for the existing native resources, right? So
okay,
and
so you
now
mean some users rely on it?
Yeah. I saw a hand from Tim.
Yeah, so just thinking about the use case a little more, imagine you have a node with scarce resources, but they're all in use. So you've got like your GPUs, and your GPUs are all in use by some workloads that are pretty light on CPU. Wouldn't we want to be able to schedule some CPU only workloads into the extra resources there, since the scarce resources are already in use?
But on the other hand, the new workload, the one that are running may be done, may be finished.
Yeah, may terminate.
Place a new one.
Yeah, I could imagine wanting to do something with priority, to say like you're allowed to schedule low priority workloads that can be preempted.
Still, we probably don't know what priority workload will be scheduled next. So
yeah, I'm not saying.
Yeah,
I'm not saying this is something that needs to be solved now, but it feels like the ability to get into this more nuanced kind of advanced scheduling algorithm is an argument for making this a first class kind of native concept and not layering it on top of taints and tolerations.
Yeah. That's a good point. So I think it's kind of, I'm thinking whether this is similar to capabilities, but probably the rules should be different. It's
I think we were originally discussing them together, and ended up on the place where the requirements and use cases were different enough that it didn't make sense to continue talking about them together. I think one explicit difference is capabilities are kind of a hard requirement, whereas what we're talking about here is maybe a softer.
Still, that would be a rule that applies to a node instead of the scarce device, right? Because I was suggesting at some point that maybe we should do similar thing just based on those devices, so tainting them and adding tolerations, but it won't work because the point is to protect the scheduling on a node, not protect scheduling on the device.
Yes, unfortunately.
That's why putting the logic into the array plugin would be a little bit incorrect, because it's about protecting node, not about protecting the array resource itself. But I think we could do it as a separate plugin, because the separate plugin can have all the information about resource claims already.
Mm-hmm.
It can do filtering. It can like read configuration from API server, whatever rules or policies we apply, and it will simply filter out those nodes for which we don't want to run pods on them.
Yeah, that would be nice. Oh, just a side question. So, how the scheduler plugin, the order of running scheduler plugin be decided? Is that all depends on how it's being configured? Or is there a way? Because if we go with the extra plugin solution, then we want it to be run at least after the DRA plugin, right? So we get the information. So just curious, because I didn't find it in the code.
Yeah, it can be configured.
Oh, nice. Thank you.
Yeah, I wondered whether we could make it a part of the taint and toleration plugin. But if we do it during filtering, so on one hand, we could do implicit toleration in this way, but I think it would be pretty hard to describe what are the criteria for tolerating.
I don't think tenant toleration plugin would work, just only because people might configure it to run before other plugins. So it's not guaranteed we have the clear information we want to decide if we gonna add the toleration or not.
Right, but if we have a taint, then this plugin will always reject all pods which don't have toleration. So we cannot add another plugin which will enable pod scheduling. We can only add plugins which can like deny scheduling.
Yes, that's definitely valid. Then we have to figure out a way to hold the rejection in the tenant toleration if we detected the taint, and then like add the toleration later in a separate plugin. I guess it's going to be needed some extra actions.
That's why it would be better to drop the approach with tolerations and taints. Then we can put it anywhere into either a new plugin or make it a part of the array.
But my only concern is at that point when we're running the tenant toleration plugins, we don't know which device is going to be allocated. So we don't know if the toleration is needed because people might put mixed of resources, right? And we cannot see for sure if scarred resource is needed at that point.
Yeah, but what I try to say that if we don't recommend using tainted toleration anymore and just create rules in API server, then any plugin could apply those rules during filtering. It could be either the array plugin or a new one that we could create.
So add a rule for seeing which node is
The
appropriate.
rule would basically say when we don't want to put a pod on a node. I'm not sure how to express those rules, but basically they should be about not scheduling on pods if pod is not using some resource that is available on scarce resource.
First, I have a couple concerns on the performance because then that means it's going to run on every incoming node request. And second, like even if we kind of block node from so it will be a very kind of not strict policy, right? Because at that point we have no idea the resources or devices the pod are going to be needed.
Well, in filtering phase, you should know everything. Okay, you mean okay, so in filtering, the resources will be not allocated yet by the array plugin, but so that's why it would have to be a part of the array plugin because the array plugin knows what is the recommended resource to attach for a pod.
Okay, cool. Thank you. Yeah, I might need some time to go to visit their plugin again because I still have some questions, but maybe we can discuss later.
Sure.
Thank you.
Yeah, the way I understand it is the array plugin during filtering is trying to assign resources that are requested.
Oh, I see. You mean I see. I missed this part. Sorry. Thank you. So it's during filtering. So at that point, it's already like kind of
Yes.
decided. Yeah, cool.
Yes,
Yeah, that makes sense. That makes a lot more sense.
decided, but then at the end, scheduler decide which of those nodes to pick based on scoring.
Okay, cool. Yeah,
But
thank you.
Sufficient to discard the nodes for which the resources are not used.
Cool. So then we don't take tens into consideration at all.
That would be my recommendation.
Thank you.
Okay, so do we have any other topic? Probably not. So thank you, everyone, and have a good day.
Thank you all.
Thank you. Have a great one.
Bye.